Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hey everybody, welcome to a brand new episode of the Clear to Send podcast. Glad you guys are here with us on this brand new episode where we're going to talk about 11K and 11V, just kind of a high overview. And I'm here with my co-host, Francois Fergus. How are you doing, Francois?
I'm very good. Hey, Roel, how are you?
I'm very well. It's early morning. It's a good morning. And we started getting into it with 11K and 11V and decided, why don't we talk about it real quick? Kind of go into why it's used, just kind of an introduction to it, and then we'll actually do a deeper dive in a future episode.
Yeah, we could do a deeper dive, and then maybe we can share a couple of tips we've used to actually study it in our packet captures. Yeah,
I think because they're two interesting amendments, right? That they're not part of the standard, and it's supposed to help our devices improve the way they move around on the wireless network. But for some reason, I don't really see it used often. Do you, Francois?
No, yeah, that's a thing. Is if you read about 11V, 11K in the standards, you see a whole bunch of cool features. But in practice, we don't see them very often. We do see some of them, but not all of them, and it's not very it's not always used, even though sometimes it's advertised by the client devices. And I think that's where the complexity comes from with 11V and 11K is it adds, talking about complexity, it adds complexity to the client devices and to the Wi-Fi drivers of the client devices. So some manufacturers probably don't want to bother too much with it. And also the features have to be supported by the AP. So and in practice, it's not all features of K and V are supported by all APs. So it makes it a little bit more complex to make it happen in practice.
Yes, I agree. When it comes to the infrastructure side, it may not be enabled, right? It's something you have to turn on to make it work. And then there's the question of, will my device use 802.11K and V? So there's the other part is if those devices don't support it, why even enable it on your network, right? And so you have to do a lot of digging, a lot of research to figure out if these benefits will be fruitful on your wireless network.
Yeah, and if you look at the amendments and when they were published, they're almost 10 years old.
They're very old, yes.
Yeah.
Older,
so we still haven't
older than my
figured it
Wi-Fi
out.
career.
Yes. So yeah. So I mean, they're very appealing to us engineers because of some of the features they provide, and they could really solve some pain issues we have in our enterprise environment. It's just very hard to implement everywhere.
Yeah, I would agree with you there. I would say, hey, 11K and 11V could definitely improve how our Wi-Fi networks are used in the enterprise and in many large installations, right? Even the small ones, because when we get into it, we'll talk about why that is. But I find that the biggest hurdle here is on the device side. It usually is, right? Usually our problems are on the device side because of the A, lack of support, or B, the way it was implemented, it probably does not work the way we think it does.
And also in Wi-Fi, if you think about it, the client device has actually a lot to say in terms of, how it connects, how it roams, and, how it adjusts a lot of things, data rates. So the client is like has to make some key decisions that will definitely impact its connection to the Wi-Fi network, right? So that's also like a big part of it. If you think about other type of wireless networks like, LTE, or a lot of things are controlled by the base station.
Right.
In Wi-Fi, a lot of key decisions are left out for the clients to make.
Yeah, and I'm trying. I remember I was having a conversation with somebody, and we were talking about not just 11K and 11V, but how Wi-Fi is in comparison to cellular. And the person I was listening to said that cellular is starting to pick up some of the things in Wi-Fi, and Wi-Fi is starting to pick up the things in cellular. Like we're seeing.
I agree.
We're seeing that mix there, and I think that's what Wi-Fi is trying to do from cellular, is try to make it a little bit more deterministic and have a little bit more control over that Wi-Fi network, so that way there is more reliability, better roaming, because in a way we do have some technologies competing with each other, and we have the capability to make it better. It's just that we don't see this implemented anywhere.
Yeah. All right. So let's talk a little bit more about. You want to start with what, 11V maybe?
Yeah, well, I do want to mention. So I look at Apple and Samsung to try to push for these, right? So Apple does have a document about using 802.11k and 11v, and as well as 11r, and they have a really good document about what they support with it, how it improves client roaming, and they even talk about the versions that are supported, and it's mainly on the iOS and iPad OS platforms. So nothing about Mac OS yet, which I wish they would support it there, but we'll link out to the show notes for all that.
Yeah, and also Samsung have a similar document as well, where they mostly focus on roaming, but they talk about they talk about how their algorithm works as well.
Yeah,
it's nice to see.
It is.
They call it enhanced roaming algorithm.
Enhanced roaming. Okay.
Yeah.
So yeah, let's dive into 11K first. How about that?
Oh yeah, sure.
All right.
Yeah, so 11K is so the I guess the technical term for 11K. Let me just get my notes.
Yeah, we find it hard to memorize all of these. It's the
we did prepare for that a little bit. But yeah, if you in the standards, if you search for 11K, you're not going to find much information. But if you search for radio measurements,
it's radio measurement. Radio resource measurement. That's
radio
all.
Resource measurement.
Because if you search for 11K in the standard, that's all you're going to find. The very first one that just says 11K. And then it'll say what it really is, which is radio resource measurement. So that's what you have to look for in the standard.
Yeah, and the name of the section is actually radio measurement, and it's section 4311. So I know they renamed it, I guess. But
they moved it around.
Yes, they moved it around. But that's if you look for this, you're gonna find all the different features under 11K. And the one that we see most of the time is the neighbor report. So you might probably already heard about this one. So the neighbor report, it's just a client device asking the AP if it can just send information about the neighboring APs. Right. So clients connected to an AP, maybe it needs to roam. It's going to ask its AP, the AP it's currently associated to. Can you give me a list of candidates for me to roam to? And then the AP will just help in defining which are the best candidate for that specific clients to roam to. And the advantage of this is the clients doesn't have to scan the entire frequency band to find the best AP. It can just focus on the channels the candidate APs are using. So it actually speeds up the discovery time and the roaming time.
Yeah, it actually doesn't have to do the discovery as much, right? Rather than having to go off channel and go scan and send beacons, it just has this neighbor list that the AP provided it to. And again, that's the most common part of 11K is that neighbor report, because the 11K, the radio measurement, is supposed to help these clients understand the environment in which they're in so that they can make better decisions.
Yeah, exactly. That's the whole point of it.
And do you see this, Francois, at all in your environments, the neighbor reports and requests?
Yes.
Oh,
So it depends. It depends on the devices, um, and and that's something. Yeah, I guess we mentioned already, but that's going to depend on the device and if the device supports it. So when a device connects to Wi-Fi network, so when you go through the association process, um, then that's when the client will tell the API, I support these features, and that's when the API will answer, okay, I support those features as well. So now if you send me a neighbor report request, I'm gonna understand what you're saying. And so when the client connects, it kind of know if it can leverage those features or not. It doesn't necessarily mean that it's gonna use them, but it can if it wants to. And that's gonna depend on how the Wi-Fi driver is implemented on that given device. So in the testing I've done, I've usually, done it from an iOS device and then from an Android device. Kind of compare the two behaviors, like from a Samsung device and from a Apple device. And I've seen neighbor reports, from iOS devices, definitely.
Yeah, and I have
yeah.
The most I've seen from 11K in my tests in my lab is actually looking for the neighbor report, because I wanted to understand how that works. I think that was around the time I was trying to test the macro micro cell, because that's where I see both 11K and V used a lot for macro micro cell with Cisco, is trying to help transition devices.
Yeah. Can you hear me?
Yeah, I can hear you.
Okay. Yeah. So I mean, this week I've done some work at home with the 3 APs, and that's the piece we don't know, right? We don't know when the clients will just send the neighbor request, and I think it might depend also on how many APs it hears broadcasting the same SSID.
Yeah, right? I think that's all part of the device algorithm. And because I find that most devices will just make the request the moment they have successfully associated. That's just my thinking, because I think you would want to know who your neighbors are right away once you've associated, because then you never know when you might have to roam to another AP if the device is moving.
And you already have the information when you roam.
Yeah. Because in my lab, I have an association request frame, and immediately after the device sends a neighbor reports request to the AP.
Yeah, and then right after that, the AP answers with a neighbor report response.
Yep.
And in that response, you should see, the BSSID of the other APs, and most importantly, you should see the channel
number. Yeah. So that's what I have. It shows I only had one other AP in this case, and it lists the BSSID of that AP, and I also provided some information on that BSSID, right? What if it's using security? There's actually an element in there called AP reachability, and so like a lot of these we'll probably dive into in a future episode when we do a deeper dive on this. But it does give the operating channel number that it's on. So then that way your device goes, all right, I need to roam. I do see this BSSID on channel 6. That's where I'll roam to, rather than having it to have to scan again and go, all right, let me send some beacons out, get probes, and then we'll get a probe response and then associate it that way. And then if you don't have 11R enabled, right, we didn't even talk about this, but if you don't have 11R enabled, it won't be that fast BSS transition. And that's where I see 11K and V actually being leveraged more, is with fast BSS transition.
Yeah, it's gonna help you to roam faster. A fast transition is not, like 11R is not required for K and V, but they would work really well together.
Yeah, it would work really well. The K and V still help in some ways, and you have a neighbor report at least, right? Now I'm not sure how a device will react to not having 11R enabled, but having K and that neighbor report. That's the part I think I wish we understood more, was how a device uses the neighbor report. Like,
Mm-hmm.
because you have a neighbor report, but how do you know, how is the device picking? Like, let's say you've got 3 APs in that neighbor report. They're all fairly, signal strength is fairly strong. How do you pick one?
Yeah.
To which one?
Well, I think it will. I think what it could do is just rely on the channel. So if you picked up 3 APs and they're on channel like 40 and 44 and 149, so then it will just engage its normal roaming mechanism. But instead of sending a probe on all the channels, it will only send a probe on those 3 channels, and then it will only take into account the probe responses on those 3 channels coming from the specific BSSID, and then it will just, the normal roaming mechanism will just kick in, but only on those probe responses.
Yeah,
see what
that's
I mean?
a good point. Yeah.
Maybe, I don't know. I'm just
that sounds like a
speculating,
really good way to do it. And even if you don't have 11R enabled, it'll probably use something like what is it called? PMKID caching, right? Like some of the older caching methods to try to opportunistic key caching to still somehow make it faster to roam.
Yeah. Yeah. And then with 11K, on top of the neighbor report, what I've seen as well is something called radio measurement request and response. And that's when I guess the AP is trying to understand, how I guess the client devices is seeing the RF environment or the radio environment. So the AP will send what's called a radio measurement request. Right, so it sends that to the client, and it specifies which channels it's interested in. So most of the time, it's the channel the AP is actually configured on, and then it will specify also additional information such as the SSID and so on. And then after that, the client is supposed to respond with a report, a radio measurement report. And that's when in my testing, I've seen different type of reports. I've only seen this on the iPad, but I see that most of the time the iPad will just respond with a report that has a refused status. So it would just there's something called a measurement report mode. So it will just say, okay, I refuse your request, and it just sends nothing apart from that. But once I was able to capture, a report answer with some data, and then, and then in the data you see, it gives a couple of indicators that I think are interesting. It gives something that's called the receive signal to noise indicator, right? So it's going to give you kind of an idea of what the SNR is. And then it has something called the receive channel power indicator, RCPI.
Wow, that's actually really good information.
Yeah, and that, if you look in the standards, that's when you start to see a whole bunch of math going on.
Yeah.
And then it tells you, and then you have to do some sort of formula to find out exactly in dBm what this value is.
Yeah.
Right. So it gives you, in your packet capture, it will give you a value in exa. So for me, I had like B8, and then in the standards, it gives you the formula to actually convert that into a dBm value. And my dBm value ended up being minus 14 dBm.
Whoa.
And I think it's because I was really close to the AP.
That's really close to the AP.
Yeah. Or my calculations are off. That's possible too.
Yeah, I mean, it's something that we have to try to figure out. And I know for any formula I see in the standard, I ignore it. Like I'm not doing any math. I'll let the devices do it. But it's good to verify, right? It's good to, it's nice that you see this information, because that's what the device is going to use in order to make that intelligent decision of where I need to go next. So yes, you could have a list of 3 BSS IDs, but if you've got that that measurement, right? That radio measurement that you were just talking about. And it's got that formula. It could take all of those details from those 3 access points that are in the neighbor list and make a decision going, all right, here's a signal strength for each of these. Here's the channel load for each of these channels. And which one, depending on that algorithm, again, that's probably something that's only known to the device manufacturer, which one has the best measurements for me to roam to. So that's the one where I will make a probe request to and join. So I think that's where a lot of these details, which within 11K, really come in handy, is having to implement all of these features. But again, not every device implements all of these features, and not every device will analyze it and use it the same way.
Yeah, and also all of this data in the report is sent back to the AP, so the AP can actually, after that, could leverage some of the 11V features to tell the clients what they should do in order to get a better connection.
That's a good transition, Francois, to talking about 11V.
Yeah, exactly. And I'm keeping some stuff for the next episode because I run into interesting stuff with Wireshark.
Was that your channel switch notification saying, "Hey, let's move to this next topic"?
Yeah, exactly. And and I found some interesting stuff in Wireshark, but I'm going to keep that for the next episode. Oh, okay. I'm teasing a little bit. Right.
Yeah. Again, we're just talking about like an overview of these two and how we've seen it in our environments. A lot of times it's more in the lab, but I haven't been able to see the devices in higher ed use these technologies. And I have one gripe about this. I was working with one manufacturer. They developed one of those cameras that operates on wheels. So somebody it's like a video conferencing unit, but the person on the other end can control the robot, but their face is on a screen so they can drive it around.
I was going to say, is it the return of the cows, the computer on the wheels?
It's a computer on wheels, but
okay.
It's just like a robot, and somebody controls it, and you see their face on a screen. So they have cameras, and they can see where they're going. And this manufacturer was asking me about Wi-Fi because it wasn't working very well. And so for one, I told them the environment that they're trying to use it in is not designed for roaming. It's an older installation, so I had to redesign it. And then after that, they were saying it still wasn't working very well. And so I asked them if they had supported 802.11r, K, and V, because since it's using video, like we can have better roaming capabilities by using standards. And they were kind of looking at me, and they didn't really know what I was talking about, so they escalated it on their end. And they basically came back with, we don't support those. We don't have that implemented. And so the way around that is they put in 2 Wi-Fi adapters into the unit. And so one adapter is used to associate, like it's its current association. The second adapter is used to go find the next AP, and then it'll switch between the adapters. So once the other adapter associates to another AP, as the signal strength of the first one starts to get lower, it'll switch over to the other one. And I was like, oh, okay, well, that's one way to do it. But you could have just leveraged standards, and we could. But I see what they're trying to do, right? Like they're trying to get around not having to deal with somebody's Wi-Fi network. They're trying to control on their end. But so I had to educate them, like, hey, you should also implement these, so that way I could help you try to roam. Like my environment can tell you where to go and send you a neighbor report. And so that's an example of maybe like device manufacturers not knowing that these are available to them.
Yeah, that's also another problem, right? But that's where the Wi-Fi Alliance is supposed to say, hey guys, you should come to the Alliance. We'll tell you what to do.
You got to pay to play though in the Alliance.
Yeah, you're right. You have to pay. Yeah.
But in that
that's why we're not part. That's why we're not part of it.
Yeah, we thought about this. We thought about joining the Wi-Fi Alliance, and then we were like, yeah, we don't make that much money to to join. But in that case, this is where I was trying to test 11V, because in that environment I had macro microcells. Right, I had a Cisco deployment, and I was leveraging macro microcells. I had dual 5 gig too, and so I wanted to test it out and see how does it work, right? So we talk about 11V. 11V is used for helping devices transition to make a better transition to another BSS ID. And so 11V will creates that enhancement for the wireless network management. Go ahead, Francois.
No, yeah, I was going to say there are different aspects of 11V. One of it will be layer 2 management of attached stations. Second one would be monitoring the attached stations. Third one is the one you talked about, the configuring the attached stations, and then the last one is updating the attached stations. Right. So yeah, so the idea is, like you said, is to provide more information to the associated clients so they can take better decisions, or just advise them on what they should do. And then it's not like mandatory. It's just like advertisement, I guess.
Yeah.
And then the client devices will always have the last say in terms of what they want to do with that information.
Because if they don't support it, they just don't do anything with that frame from the AP, right? So BSS transition is probably the most commonly used one from 802.11b. There's also notifications of when the AP will change channels, for example, and it will tell the client, go here on this channel. That's where I'm going to start operating. So there are good features in 11v, especially with that transition management. But again, it's like, to me, if the devices don't support it, but your infrastructure does, you're just sending a lot of unnecessary communications over the air when no one's listening. It's like you're trying to corral all these devices. You're like, hey, let's come move over here, but they're not listening to you, right? It's like you're talking to your kids. Well, let's go over here, guys.
In my testing, I wasn't able to see 11v frames. And I did a whole bunch of walking and testing and roaming. I was trying to generate those frames, and I couldn't generate. And I did it on both 2.4 and 5 gigahertz. And I probably like over an afternoon, I probably generated close to 100 rooms, and I didn't see any with the equipment I was testing. I didn't see any 11v frames.
Yeah.
So I think those frames would be more like unicast to the client stations that supports them, and very targeted, I guess. But yeah, it's not something that I was able to reproduce in my lab environment, which was unfortunate.
Yeah, I find it was like you. I thought it was difficult to try to create, because I was playing with my environment. I had 2 Cisco APs. And this is where I found that it probably is better used when you have a lot of clients. Because I was trying to do the macro microcell, and I wanted to try to transition from the macro cell to the microcell, and I wanted to see that in action. And I did so many tests and probably not as many roams. The roaming piece was the hard part. And I did manage to catch this very briefly because I was using a dual 5 gig on the AP. And I started from the farthest away. And of course, my lab is my home, right? So my house isn't that big. I can't really... if I wanted to go on the edge, the very far edge of the cell, I'd have to go outside and then try to walk inwards.
That's what I did.
Yeah. I even lowered the power so low so that way the signal wasn't going that far. But even then, it was still hard because both signals strengths were pretty strong. And also, additionally, my AP was not mounted on the ceiling, right? So I also find that...
Okay, where do you put it then? Under the desk?
So this is where I got really creative, Francois. I actually tried to create attenuation between the macro and micro cell because both signal strengths were strong for my device. So it wouldn't transition. And so what I would do is I would either put my body in between my phone and the AP or other things to try to make signal strengths lower. And so you have to understand how the signal gets propagated out of the AP, because the microcell and the Cisco APs, it's better if it's mounted on the ceiling because of the way that signal is being propagated out. Well, anyways, I was able to get a BSS transition management request frame, right?
That's
and
nice.
so yeah, that's that management request frame comes from the access point. The access point's requesting the client to move to another channel. And so because I only had one AP, the management request frame says, hey, I've got a candidate in this list. And there's different settings. And with Cisco, you can tune a lot of these settings. So you can even determine how long it would take before that disassociation or termination happens to that client. But it would list the AP in a neighbor report, and it goes, hey, here's the BSS ID of this candidate in my neighbor report. Here's the information about that BSS ID. Here's a channel it's operating on. And if there's more than one BSS ID, it'll actually send a candidate preference. And so there's a little value to that preference number. And then my device was responding to it. It actually says status code 1, which I don't even remember what that means. We'd have to look at the standard. But then the AP just kept sending it. It kept saying, hey, here, I'm requesting you to go here. And I don't think my device did it.
It's like, okay, thank you.
It's like I acknowledge your request, and I'm not gonna do anything.
It's like when you tell your kids to do something, and they're like, yes.
Yeah, and
they don't do it.
Yeah, it's like talking to kids. This is exactly what 11K and 11V is. You've got a parent who's your AP, and you're trying to tell your kids to do something. All your clients, and you're like, I want you to move from this room to this room. We're going to bed, right? We're going to go to your room. And they just don't do it. That's exactly how this happens in the real world. So in the end, my client did not move with 802.11v because I believe either one, there was no load on the on either channel, right? On the macro cell, there was no load. I had one device on it, so I don't think it wanted to move because the signal strength was good. Everything else was good. That's my only reason why. I don't think there was enough to trigger that device to actually transition over.
Okay.
So I have not seen it successfully yet. I'm sure it's happened. I just haven't seen it.
Well, if you read, like I was reading the Samsung document I was talking about earlier, and they have a whole section on BSS transition. They call it BSS transition management, and they talk about it a little bit. But even with my Samsung, I wasn't able to generate those frames. So I think they have very specific triggers, right? Yeah. And they have. They're talking about channel utilization. So I think with the issue I had in my house is that the Wi-Fi is not busy.
Yeah.
Enough to trigger those things. Because they're talking about like 60% of channel utilization. Pretty much sure at my house I don't have that.
Yeah. And this is why with 11V there are timers on the Cisco that you could tune to disassociate clients. Right. The infrastructure could just disassociate the client and have it try to join the other BSS ID, which I'm not like too big fan of that, especially if you've got voice or low latency applications that don't like any kind of disconnect. So I didn't have that configured.
Yeah, and also like something that the AP will do is that the AP can actually set the severity of the recommendation. So you can say, oh, this is just a an advertisement, and then if you can send it again and say, oh, you should really do this, and then you can send it again and then and tell the client, if you don't roam right now to that AP, I'm going to disassociate you.
Yeah.
So it has the ability to give the severity inside those messages.
Yeah, that's called the disassociation imminent.
Imminent,
like it's warning you. It's like disassociation's imminent. You better go over there.
Yeah, it's like when you tell your kid, okay, you go now, you're going to time out.
Yeah, you better go to sleep. I'm going to give you 2 minutes to do.
I give my daughter 3 seconds.
3 seconds. Yeah, maybe I should give seconds instead of minutes. But with my kids, I use an actual timer, right? So this is very similar to 11V. They've got timers. It tells the client, hey, you've got this many microseconds before I'm going to disassociate you, so you better move over. And sometimes the client just doesn't care, right? And then it could get disassociated, but it does not mean that the client will just reassociate to that same BSSID, right? It could do that. Because the client is the one that decides where it wants to go.
Yeah, and I think that's when you can run into issues with 11V is if the AP keeps on disassociating the clients and the client keeps on reconnecting to that same AP. After a little while, the AP could be blacklisted.
Yeah.
Right. And then it's sometimes like with iOS, I know it's more than the AP that's blacklisted. It's the entire SSID.
Yeah.
And then you have to restart the phone, or you have to turn the Wi-Fi connection on and off. Yeah.
Yeah. So there are things, there are negative effects to doing this. And again, if you really understand how the device works, and I didn't know this, that what you just mentioned, Francois, like that Banlist, I didn't know that until about, I think, last year. And I'm like, really? Like there's a Banlist? Like nowhere have I seen that documented.
I learned it from Jerome Henry at one of his presentations at Cisco Live.
Yeah, see, I must have not been paying attention during that presentation. But
that was the one in San Diego.
It would make sense from a device perspective, right? And this is where devices try to have their own algorithms. If you cannot associate to that BSSID, you should stop trying to. And so they would, I can see how they could ban it. Now, banning a whole SSID, now that's kind of excessive and probably poor programming on the device manufacturer side. But BSSID, I can see that. And so, and I guess you could have the same functionality on the infrastructure side, where if on 11V, if the AP decides to disassociate that client, it could deny its association and not respond to it, right? Kind of like almost like band steering, just kind of steer it to another BSSID.
Well, and I think that's one of the reasons, like if I were like an AP manufacturer, I wouldn't send a disassociation frame for these cases. But I think for Cisco, I think it does when you enable the load balancing stuff.
Yeah.
Right. But if you don't enable load balancing, I don't think it will. So I guess it's going to depend on which feature you have enabled.
Exactly. Yeah. And there is there are different codes. So we'll go into this in the future because I think 11V has a lot more to talk about when it comes to transition, because 11K is more of the focus there is on radio measurements, right? There's not actual actions going on the device side where it has to move between BSSIDs. So there's different configurations, different options within 11V, different timers, different status codes, the reasons why maybe a device was disassociated and whether it's leaving, APs changing channels. So it could utilize the channel change information, the element there to tell a device like, hey, I'm no longer gonna be on this channel, move to this channel. It could try to use that to steer it to another to the like a micro cell scenario. So I mean, there's different things to talk about, and we need to go through the standard figure out what to tell you guys.
Yeah, and I guess that's what we can keep for the next episode. We'll tell you how we can actually, find all of these informations inside our packet captures. For us, it involves a lot of going back and forth between, the standards and the packet capture. And I think it's a very interesting work to do in order to better understand how the standards are structured, and also in order to better understand how it works behind the scenes.
Yeah. And then if you've got a certain set of devices, this will help you understand, all right, well, maybe these certain features I could tune on my controller, if you got a controller, and then do it based on device. So you'll gain an understanding of how your devices actually communicate with your Wi-Fi infrastructure.
And you could see if it's enabled, and then you could see if it's used.
Yeah, that's the thing.
Yeah,
if it's actually used, because if your device is just rejecting everything or not even responding, or responding with what was that response that you got from your device, Francois?
Rejected.
Rejection. And if you see too many of those at that point, then that's when I would just disable that feature, because there's too much communications happening over the air that do nothing. And you could gather how much of that traffic is actually just these frames like that have no functionality, and that way you can try to improve it a little bit more. But,
yeah, and also we'll provide all the Wireshark filters, so you can reuse those filters to kind of see if you see those specific frames.
Yeah,
it's going to get very specific.
Yeah, you'll get down to the type of like BSS transition frame. So you can see all action frames, the management action frames, or you can just drill down to the exact frame. So if you're trying to see the BSS transition management request frame, there is a filter just specific to that.
Yeah, exactly.
All right. So, I mean, we don't want to dive into that anymore. We'll create another episode that goes into the more technical details of it. But Francois, What are you working on this week?
I'm actually teaching an Ekahau class this week.
Nice.
Yeah. So, and I'm doing some renovation in my house, in my basement. So I've been working on that this week. So I still have some to do. So I'll be probably, doing that and teaching. So yeah. That's pretty much what's it for me.
That's already a lot of work. Training for most of the day, and then when you're done renovating your house, that's
going to be the plan for me. I think.
Right. Very cool.
What about you?
I've been trying to figure out how to take a break, right? Because we're on the screens all day, meetings all day. I'm just getting tired of it. So I can't go outside.
You have a lot of fires right now.
Yeah, so I can't go outside because of the fires. It's in San Jose. The air quality is horrible. I think it's in the red. Like, you shouldn't be outside at all.
Wow.
I mean, I can drive somewhere else, but then there's fires elsewhere. So.
Yeah, I know. I've seen the map. It's crazy.
The whole West Coast is on fire. I went to San Francisco, and so it was good there. So I'm just trying to figure out how to make sure I take a break, get my mental state in a better place, and then I'll probably finish a couple more projects that I have, just some reports that I need to generate, and then probably work on some of the extra stuff that we have, some stuff for Clear to Send, and then maybe some videos that I've been neglecting to do.
Oh, okay. Well, hopefully the situation outside improves.
Yeah, I think it will. It depends, because this weekend, today and tomorrow, we're supposed to have lightning storms. So hopefully that's how the fires were started. We had a huge lightning storm, and then everyone was like, "Wow, lightning!" And then the next day, it was like, "Whoa, fires!" And that's what. So hopefully they don't start new fires.
Hopefully the rain.
helps. We need water. Yeah. So we'll see if Mother Earth will give us water. But other than that, I'm pretty good. I'm not too close to the fires. If too close meaning I'm not within 5 miles of it. I'm maybe 15 to 20.
Okay. All right. Awesome.
All right, guys. If you guys want to see the show notes, head over to cleartosend.net. I think it's /234. I forgot the number already.
234. Yeah, you're right.
All right, so head over there, and if you guys have gotten 802.11k and V to work successfully, let us know in the comments. Maybe share us what you've seen, what you've come across, and some tips. And then in a future episode, maybe the next one, we'll kind of dive deeper into 11k and 11v. So thanks, guys.
Awesome.
We'll see you on the next episode.
Have a good week.